Here's an example in which I do not have series expressed in terms of the sum of the a sub n. So let's you and I do the work of finding what the pattern is. So rewriting the series in summation notation. Looks to me like I have a sign change from term to term, so it's an alternating series. So it should involve in the numerator position a factor like this, I think. I could be wrong, maybe it's n plus 1. Let's check it. If n is equal to 0, this is positive. My first term is positive, so it checks out. If that first term were negative, then we change this to an n plus or minus 1 or n plus any odd integer. Next on my list, let's take a peek at these numerators and absolute values. They certainly seem to be powers of 2. But it's not really working, because when n is equal to 0, this gives me a 1, but it should give me an 8. But notice if I replace my n with an n plus 3, then when n is equal to 0, I have 2 cubed, which gives me the 8, which is the first term's numerator and absolute values, and that's exactly what I want. Now downstairs, notice that there's a progression by 1 by this first factor by denominator. And so it looks like I've got a factor of n downstairs, but let's check it. If n is equal to 0, do I get 3? No, I don't. So I do think it should be an n plus something, namely in this case a 3. Now I can check when n is equal to 0, 1, 2. You'll get a 3, 4, 5 as the first factor downstairs. I do think likewise the second factor is a factorial of the first factor increased by 1. And I think the only thing I miss is that I've got an extra variable factor, namely that. Now, this infinite series is equal to this infinite series, but just rewriting using summation notation. Now, to find the interval of convergence, let's you and I go ahead and take a peek at using, again, the ratio test. So the absolute value of the n plus first term gives me this. Neglecting that factor. The reciprocal of the nth term gives me this in absolute values. Neglecting that factor. Now multiplying by the ratio of the n plus first terms component involving this factor to its nth and absolute values, get a lot of cancellation. I'm merely left with the absolute value of x. Now remember, this has nothing to do with n, so it's not in the limit. If you want to, you can pull it straight out front. But we're using the ratio test. The ratio test says we have convergence if this limit is strictly less than 1. So let's solve this inequality for x. Let's see, I guess I can't use my eraser conveniently. I'm just going to have to write this out. Now, it seems to me that I'm experiencing cancellation here as well as here. I don't think I see any else. Oh, yeah, that's about it. And in evaluating limits, this certainly goes to 0. So here's a question. What real numbers have the quality that when you take their absolute values, double them, multiply by 0, I'm necessarily going to get something less than 1? Well, I think the answer is for all values of x. And so I think the radius of convergence is all real numbers. And the interval of convergence is for free from here to here.